math major, so let's take 6 numbers and see what I can do. Here I have integers, which are whole numbers and their negative opposites, from negative 20 to positive 20. So let's pull out 6. I have negative 2, 9, 18, negative 5, negative 7, and 4. From these, we can take 18 and subtract negative 2 from it to get 20. And 20 is interesting because it's a multiple of 5. But this is not just a party trick. Any set of 6 integers that we pull out of this hat or anywhere else will always have at least one difference divisible by 5. And today, we are going to prove it. But first, we must learn about the Pigeonhole Principle and the Quotient Remainder Theorem. This is the Pigeonhole Principle in math terms. Any function mapped from a larger set x to a smaller set y cannot be injective. This means that if I were to try to draw arrows from this set x to this set y, I wouldn't be able to give each element its own arrow. Some of them would have to map to the same element. But now, let's try to understand this with actual pigeons. So here I have a group of pigeons. If we also have a group of homes or ledges, what the Pigeonhole Principle tells us is that if we have too many pigeons, or more pigeons than ledges, then the pigeons will have to share. If they all decide to go in the building at once, there will have to be more than one pigeon in at least one of the ledges. Now that we've learned about the Pigeonhole Principle, we need to learn about the Quotient Remainder Theorem before we can answer our question. The Quotient Remainder Theorem states that if you give me 2 integers, q and d, I can uniquely write them q as a multiple of d plus some remainder r. This multiple must be an integer, as q and d are also integers, and this r must be a natural number which is between 0 and the absolute value of d. To see an application of the Quotient Remainder Theorem, let's write each of our 6 integers from before as a multiple of 5 plus some remainder r. You'll notice that some of the r's are repeating, which of course is the key. So now we come to our question, which involves 6 integers. And by the Quotient Remainder Theorem, we write each of these integers as variables x as some multiple of 5 plus some remainder r. Now this remainder r is bounded by 0 and 5. So we have 6 of them, 6 r's, r1, r2, up to r6, and only 5 possible values for r, 1, 2, 3, 4, and 5. By the Pigeonhole Principle, if we wanted to map between these 2 sets, at least 2 of these r's must have the same value. Suppose that the first integer and the fourth integer have the same remainder r. So then we can take these and subtract them, and then we get 5 times m1 minus 5 times m4. We can factor out a 5, and here we have a multiple of 5. 5 times some integer, which is m1 minus m4. So for any set of 6 integers, we have just shown, using the Pigeonhole Principle and the Quotient Remainder Theorem, that there will always be at least one difference divisible by 5. Here are some big takeaways from this video. Firstly, there's nothing special about 6 integers and 5. For example, any set of 3 integers has a difference divisible by 2. Secondly, the ideas presented here give birth to modular arithmetic, that is, math with remainders. Finally, modular arithmetic is all around us, especially in analog clocks, 7-day weeks, and 12-month years. Thanks for listening.